Substitution. This is a method of solving a system of equations. A system of equations is two or more equations that will intersect, hopefully. We have to find out whether or not they intersect, and the best way to do it is using substitution or elimination, okay? So looking at substitution, if I have y equals 2x minus 6 and y equals negative 4 plus 8, no, negative 4x plus 8, okay? This is considered a system of equations. Sometimes you'll see them numbered as 1 and 2. It doesn't matter, okay? This is a system because it has two equations. Now I want to solve and find out where the point of intersection is. The point of intersection is the solution. If there's no point of intersection, I have parallel lines going up and over at the same time, so we'll have no solution at that point. So, how do I do this? Well, I have the same variable on the left, y. That means I can take the 2x minus 6 and set it equal to the negative 4x plus 8, okay? So, what does that look like? Well, I want 2x minus 6 equal to negative 4x plus 8. Because they are both equal to y, where these y's are equal, the x's should be equal as well, okay? So, now we have variables on both sides of the equation. I need variable on one side. So what do? Well, I have 2x, I have negative 4x. I always say keep it positive, okay? Keep it positive. I got negative here, positive here. I can add this and make a bigger positive. So I'm going to add 4x to both sides of my equation, okay? So that's going to be 6x minus 6 equals 8. All right? Now, I have the variable on one side, but I need that variable by itself, okay? It's been a bad boy. It's been a bad boy. It needs a timeout, okay? So I add 6 to both sides, giving me 6x equals 14, okay? Now I divide by 6. So my x is, reduce this, that's going to be 7 over 3, okay? Ew, fraction, oh well. That's my x value, but I'm not done. I may have x, but I don't have y. So how do I find y? Pick an equation. I don't care, top or bottom. Let's go ahead and use the top one. So I'm going to write down y equals 2x minus 6. I'm going to use this. I'm going to put my 7/3 in where x is. Y equals 2 times 7/3 minus 6. Okay? I just took what I have for x, put it in there. Now I'm going to solve this and get y. Okay? So y equals 2 times 7 is 14 over 3 minus 6. Now I can put it in the calculator, get it. However, I'm going to show you how to do this with fractions. 6 is like 6 over 1. Okay? I need a common denominator. Common denominator is 3. That means I need to multiply the bottom and the top by 3. Okay? 3 times 6 is 18. 1 times 3 is 3. Now I have 14 over 3 minus 18 over 3. 14 minus 18 is 4. It's going to be a negative 4 over 3. Now, this is a coordinate, folks. So we write it in coordinate form. And there is your final answer. Okay? That's substitution. But wait a second. What if I don't have it set equal to each other? What if I have equation in standard form and one in slope-intercept form? Well, they're not equal, but I still can do substitution. Right here, I have y by itself. Kind of cool. Because I have y by itself, I can take negative 2x plus 1 and stick it into that y up there in the first equation. So we write this, 2x plus 3 times negative 2x plus 1 equals 6. There's my substitution. I took this negative 2x plus 1 and I put it in place of that y. I substituted it for y. Okay? So 2x plus, do my distributive property, 3 times negative 2x plus 3 times 1 equals 6. Now multiply it. 2x minus 6x plus 3 equals 6. Okay? Combine these two right here. This is negative 4x plus 3 equals 6. Subtract my 3. I get negative 4x equals 3. Divide by negative 4. I get x equals negative 3/4. Okay? Now, again, I have x. I need y. Pick one of the two equations. However, this one's the easier one because y is already by itself. I don't have to do any manipulation. So we're going to use y equals negative 2x plus 1. Okay? Plug it in. Y equals negative 2 times negative 3/4 plus 1. Okay? So y equals 3 over 2. You say, Miss Kaiser, how do you get that? Well, this 2 goes into this 4 2 times. Okay? That's how I get that. Then I add my 1. Well, 1, oh, no. No x in there. Okay? My 1 can change into 2 over 2. Then 3 plus 2 is 5. There's my y. So, my coordinate, negative 3/4 is my x, and 5/2 is my y. Okay? There's my solutions. All right? So that's how you can do this for solving by substitution. Okay? Now, you also need to solve by the numerical method. Numerical method means you're making tables of values. So if I have y equals 2x plus 1, and y equals negative x minus 3, okay, I'm going to make tables of values. Okay? If I put 0 in there, 2 times 0 plus 1, that's 1. Put 1 in there, 2 times 1 plus 1, that gives me 3. Okay? Put negative 1 in there, 2 times negative 1 plus 1, that's going to give me negative 1. Now, some students are going, Miss Kaiser, where are you getting these numbers? I'm picking them. Picking them at random, okay? But remember, I've already told you guys once before, when you're picking your numbers, you want them close to the origin. Why? Because you want to be able to graph them eventually. And if they're way out there, you can't graph them. Keep them close to the origin. Let's try this one. Okay, if I go 0, I get negative 3. If I put 1, I get the opposite. The opposite of 1 minus 3. That is -4. Okay? If I do -1, the opposite of -1 minus 3, -1's opposite is 1, 1 minus 3 is -2. Okay? So there's the numerical representation. Well, what about graphical? Well, let's grab a graph. And we're going to graph our tables. Okay? Here we go. Using black for this one. Okay? 0, 1, 0, 1, 1, 3, and -1, -1. There is my graph. All right. Now, as you notice, I'm making it go all the way through my grid. I'm not just doing a little bit because I'm looking for a point of intersection. I need to see where these cross, and sometimes it's a little far out. So make sure your line goes all the way through, please. Now, 0, -3, 1, 2, 3, then 1, -4, 1, -2, 3, 4, and then -1, -2, -1, -1, 2. Okay? And there's our point of intersection. Now, as you can see here, right here, it's a fraction again, okay? I could approximate it, but it's good enough for right now, all right? If I really want the exact, I'll go ahead and use substitution, okay? So, that's numerically, graphically, algebraically with substitution, okay? Those are your 3 methods that you will be using in section 3.1. I hope you looked at the previous video where I showed you an example along with your vocabulary, so make sure you have all of that with you for class.